Solving a system of linear equations by hand always comes down to the same mechanical procedure called Gaussian elimination. The idea is to turn a messy system into a tidy staircase shape known as row echelon form using only 3 legal moves. Those 3 moves are swap 2 rows, scale a row by a non-zero number, or add a multiple of 1 row to another row. Let's see 2 contrasting worked examples using these moves. Worked example 1. The system is x sub 1 plus 2x sub 2 minus x sub 3 equals 4. 2x sub 1 plus 5x sub 2 plus x sub 3 equals 9. And x sub 1 plus 4x sub 2 plus 5x sub 3 equals 5. We write this as an augmented matrix and eliminate x sub 1 from the second and third rows by subtracting suitable multiples of the first row. Then we eliminate x sub 2 from the third row using the new second row. Carrying this through, the bottom row of the reduced matrix collapses down to the equation 0 equals negative 1. That is a flat contradiction. No values of x sub 1, x sub 2 or x sub 3 can make 0 equal negative 1. So this system has no solution at all. Worked example 2. The system is x sub 1 plus 2x sub 2 plus x sub 3 equals 3. 2x sub 1 plus 5x sub 2 minus x sub 3 equals 4. And x sub 1 plus 3x sub 2 minus 2x sub 3 equals 1. Again, we eliminate x sub 1 from the second and third rows using the first row, then eliminate x sub 2 from the third row using the new second row. This time, the bottom row reduces all the way down to 0 equals 0, which tells us there is no contradiction, but also no equation left to pin down x sub 3. So x sub 3 is a free variable. We set x sub 3 equal to t for any real number t, and back substitute into the earlier rows to solve for x sub 1 and x sub 2 in terms of t. Doing that back substitution gives the general solution, the vector x sub 1, x sub 2, x sub 3 equals the vector 7, negative 2, 0, plus t times the vector negative 7, 3, 1. Because it can be any real number, this system has infinitely many solutions, and geometrically they all sit on a single straight line running through 3-dimensional space. So these 2 examples show 2 of the 3 possible outcomes for any linear system: no solution, exactly 1 solution, or infinitely many solutions. Like and follow for more math tutorials, one idea at a time, nothing rushed.